Good afternoon, class. I just wanted to share a video with you related to working with functions. I mentioned a few times over the past several days that this next lab activity that you'll be doing, which is lab activity number 8, is really a pivotal moment in terms of the course because what we've been doing up for the past couple of weeks, 3 weeks actually, is getting stronger in using Python syntax and building our strength in the foundational principles of Python. But we've been moving towards this next piece, which is developing Python code based on functions. So what I wanted to do was I wanted to go over a short video related to developing code that is function-based. And you can apply these principles when you start working on your lab activity number 8 and beyond. So this video is being prepared with the assumption that you've gone over some of the preliminary lecture material related to functions and you've read the material in the book. But it doesn't really make a difference if you've read it or not, if you can't apply it. All right. So what I've done here is I put together the skeleton of a very simple program. What I'm ultimately going to do is I'm going to go over the 3 types of functions. I'm going to implement them in code, and hopefully you'll be able to follow along. You can even reproduce this on your own in PyCharm. So just as a quick review, there are 3 basic function types, type 1, type 2, and type 3 that I've categorized. The type 1 function is a function that you can call the function to do something, but the function itself does not need any data to do its work, nor does it do any work that sends data back to the calling routine. And I'll explain all these terms as we go through the video. Type 2 function is a function that actually requires data from us in order to do its work. It does its work, but it also does not return any data to the calling routine. The type 3 function is probably the most powerful, and the type 3 function is a function that typically is going to require some data from us to do its work, but it doesn't have to, just like in the type 2 function. But it can, but it's the only function that actually returns data back to the calling routine. Now, the way that you can tell that a type 3 function is going to be used is you see it with a variable to accept the return data and the function name to the right of the assignment operator or the equal sign. Now, if you look at my code, you'll see an example of a type 3 function at line 19 and 20. I'm going to go ahead and put a comment in here so that you can, I'm just going to identify it. Example of a type 3 function. And you know it's a type 3 function because the function that we're going to develop and write is called getData. Now you'll notice that the format of the function is very specific. As a matter of fact, some of you had problems with your lab activity number 7 because you inadvertently started to use symbols in your code that, according to Python, you were trying to call a function and the function didn't exist, so the code failed. The way a function is written is you have your function name, in this case it's getData, and in between the parentheses is where you would actually put parameters to send up to the function. Okay, so the way a function is written, you have your function name, open parentheses, parameters that the function is going to use, followed by a close parentheses. If the syntax that you're using has the function name to the right, which is as is in line 19 and 20, and you have it assigned or assigned to a variable on the left-hand side of the assignment operator, that means that once the function does its work, it's going to return data back to the calling routine so it can be assigned to a variable. So the way that line 19 and 20 is going to work, we're going to write a function called getData. We're going to have the function ask the user for information or data. We're going to do something with that data, and we're going to assign it upon return to the variable value1, and in line 20, it's going to assign the data that it acquired to value2. But I want you to notice something very specific here. In line 19 and line 20, the function, we're using the same function twice, and that is the beauty of using functions in Python, or any language for that matter, that we can write a function that has a specific purpose and call it again and again and again. For instance, let's say you wanted to check to find out if the user actually entered an integer. Perhaps you could write a function that is going to use try except logic to check the data, but you could use that same function over and over again if you needed to, depending on the type of data you're trying to acquire from the user. So we have an example of a type 1 function. So actually we have a type 3 function at line 19. And we also have one at line 20. Now, if you take a look at line 17, the function is sitting there as a standalone, and there are no parameters that are being sent. And the way that you know that is there's nothing in between the parentheses. So I'm sending no parameters to the function output purpose, and I'm not getting anything back from the function output purpose because you don't see it assigned to a variable like you do in lines 19 and 20. So according to what it says in the definition, this function neither passes nor returns any parameters or data. So this is an example, a classic example of a type 1 function. This is a type 1 function. And then the only thing we have left is a type 2 function. And the type 2 function is a function that you write where you pass data to it. So the function process data is something that requires data from us to do its work. And so we call the function, as I did in line 22, and I'm sending it two variables. One is value1 and one is value2. And then once that data is passed into the function, it's going to do its work and then return. Now you notice there's no equal sign, there's no variable equals. That means that all the work that's going to be done in the function is going to be done within the function, and the function is not going to pass any data back to the calling routine. And I keep on using that term, calling routine. We have a function currently written right now, it's called main. And you know it's a function because we have it defined, according to Python. We have it defined in Python syntax. The def is referred to as a definition. Following the def syntax, we put the function name, and then we put any type of parameters that are going to be used. So this is a function called main, and this is the main block of code we're going to be using in our program. So taking it from the top, in our main function, we're declaring three variables, value1, value2, and sum, and we're equating them to 0. And then we're going to execute a function called output purpose. It's a type 1 function, which we're going to write shortly, and it's going to output the purpose of the program. Then I return from the output purpose function back to the main function, execute line 19, which is the syntax is written so that we're going to execute a function called getData. We're not going to send any parameters in to this particular function because we're going to do all the work up in that function. And then once it does its work, you'll see how we can send that data back. And in line 19, we're going to send the data back and assign it to the variable value1. And then in line 20, we're going to do the same function. We're going to execute the same function and return the data back and assign it to a variable called value2. Once we have our two values, we're going to take those two values, send them to a function called process data, and we'll talk about what that process data function is going to do. I think that because I have a variable called sum, we'll do something with that. But we'll talk about that as we go through. All right. So that's basically the gist of how the code is going to be executed. You notice that the definition for main is listed between lines 11 and 24. Typically, a function truly characterized is going to have a definition and then finished up with the return. But the real first line of executable code is actually at line 26, because it's at line 26 that Python looks and says, okay, what do I need to do? According to the program, we're going to execute a function called main. That's what line 26 says. And Python looks for the definition of line of the main function and then executes the code within it. Okay, so the first thing we're going to do is we're going to write a function that's called output purpose. We're going to be using that function to output the function or the purpose of the program. So we started off with define or def and output purpose. And we're going to finish it up with a colon. And there's really no variables here, right? Because we're only going to be printing the purpose of the program. So I'm going to use the output function, or print. This program will demonstrate the use of functions to process user data. Okay, and then I'm going to print quote, quote. That's just add an extra space. And then I'll say return. Okay, we're done. So again, when the program is going to execute, what's going to happen is Python's going to look at the definitions and inventory the definitions. It's going to inventory the functions that have been defined. And then it's going to say, okay, what do I need to execute? Well, it looks like line 30, I have to execute a program called, or a function called main. So it searches for the function main, it finds it, and it starts to execute. In our case, it's going to initialize value 1 and value 2 and some variables to 0. And then it's going to say, oh, I got to execute output purpose. Python will then look for the function called output purpose, which it finds at line 8, and then executes the line of code or the lines of code found within that indented block. In this case, 9, 10, and 11. Okay, so that's our first function. It's a type 1 function. It looks how it looks. It's how it's designed. Notice there are no parameters being sent in, or in this case, where the variables would be accepted, because it's a type 1 function. It does its work and then returns. The next function we have to write is get data. It's going to be a little bit more involved, but nothing that we can't handle. Okay, so as with all function definitions, we start with the DEF syntax, and we type in the name of the function. And if you'll notice, a couple of things to point out: function names must match. All right, so output purpose must be matched with output purpose. Get data must have a get data. Process data also must have a definition for process data, but we'll take these things one at a time. So all that get data is going to do, it's going to ask the user for a value. Now, since we're doing math, we want to make sure it's an integer value. So I would suspect that most of you can put on your resume that you are try, except, logic experts by now. So we're going to put that built into here. Or we could actually write another function within get data, or we could call a function within the get data function to actually check to make sure that the value is valid using try, except logic. But we're going to do that within this function. Okay. So the first thing we're going to do is we're going to declare some variables to use within the function. Now, I need to take a quick commercial break here to share with you that variables must be spoken and understood when dealing with functions in Python. Now, there are two general types of variables when dealing with code development when using functions. There's a variable called a local variable, and one that's called a global variable. A local variable is only known within the function. Global variables are known everywhere throughout the program. Typically, you want to be careful of how often you use global variables because they're vulnerable. If anybody changes the values of a global variable, that's exactly what's going to be used throughout the program, which may be what you want, but in many cases, you want to protect data. So by keeping them within the function or local to the function, you have, in essence, protected the data because they only have what they call scope, which means they have validity only within the function. So I'm going to add a couple of variables here. I'm going to call my first variable x string is equal to null, N-U-L-L. If you're not quite sure exactly what I'm saying, null just basically means it's the string equivalent of 0 in the numerical world. That's the best way to say it. Then I'm going to have the non-string version of this variable. I try to keep the variables coordinated. And so I'm going to then go ahead and try to input my values. So input, please enter an integer to use in our equation. Okay, so you know this from all the work we've done so far, that when you use the input function in Python, it pulls the data in as a string. It's that very characteristics that has allowed us to use the try except logic when we try to convert the string to an integer using the int typecast operator. So I'm going to go ahead and put my my try except logic in. So while true, let's try to integerize or to typecast the string variable xstr as an integer. So we're gonna, if they put in the number 4 and you try to do line 21, which is the trying to turn the string into an integer, if it's really a number, it's going to work. If it doesn't, we're going to have, I hope you know this by now, it's going to have the value error exception. And we're going to have to say to the user, print, you entered invalid data. Please re-enter. Okay. Now, since we're using the try except logic, the very next thing that we're going to do is we're going to ask the user to re-input their choice. Because if you look at line 21, we're going to be executing the line of code to create an integer from a string. So it's actually the same line of code that's at line 17. So I'm going to copy this down to in the except block, and we're done. Okay, so once I go to the once I have these two lines in, I have my else block, and then I'm going to execute a break. Okay, so we're not done yet, but let's just go through the code to make sure this is accurate. When we come into the function getData, we're going to initialize two variables, xString and x. xString is going to be the variable to hold the string version of the input, and x will hopefully hold the integerized or the integer version of the string, the converted string. We ask the user to enter an integer value. We go into our try except logic to make sure that value is correct. We take our string variable, try to turn it into an integer. If it was a number in the string, it works. If it doesn't, we execute the value exception or the value error exception. We process that exception and we output a message, you've entered invalid data, and then we try to get the user to put the value in again. Then we loop around and we try to integerize, and if it was a value, it'll work. The break will execute, and we're done. But according to what we have in our main code or the calling routine, this function is supposed to return back to the calling routine, which in this case is main, the value that the user entered, which is correct, which is it's verified, in other words, with the try except logic. So it's going to come back and assign that number to the variable value 1. So the way that you send that information back, notice we have to be outside the loop. It's still indented because we have an indented block for our function definition. We're going to say return. What are we returning? The data found in variable X. We're done. We are done. So we now have our second function written. When getData is called, we're going to send nothing to it. That's because we have nothing set between the two parentheses. Because getData is going to do all the work to get the data from the user. It's going to come into the function, initialize its own internal local variables. It's going to attempt to get the value from the user and go through the try except logic to verify that it's actually a number, and then return that validated number back to the calling routine, which is main, and then assign that value of X to value 1. If you're understanding the strategy, the same thing's going to happen when we try to do it again. Notice we're running the same function. It's going to come into the function, do the same exact thing. Notice that the verbiage in the input text, we have the output message, please enter an integer to use in our equation. It's very generic. It doesn't say put the first integer. It doesn't say put the second integer. Keep the language generic so you can use that function again and again and again. Okay, so we got our type 3 function done. All we have left to do now is to write our type 2 function. So let me go ahead and put this in and say example of type 2 function. And again, as a recap, you're saying, why is it a type 2? Because we're not returning a value. We're not returning a value. All right. We can turn it into a type 3, but for this particular example, I chose to make it a type 2, which means if we're not sending anything back, everything has to take place up in that function, including the printing. Okay, if we're going to get something out of this program. Okay, so that means that this variable sum is not needed here because we're going to do everything within that type 2 function. So I'm going to go ahead and get rid of that sum variable. And so I think you're catching on to how this is going to work. I'm just going to start the definition by def and then process data. And I'm going to put the open parentheses, and you have, PyCharm actually puts the closing in for you. But we got to talk about a couple of things at this point. In line 42 of this code, it's a type 2 function, and according to the definition, it says it's a function that allows parameters to be passed in. It doesn't have to, but it can. In this case, we're sending 2 numbers into the function. What we're going to do is we're going to sum the 2 numbers. We're going to add the 2 numbers. We're going to display the sum and then return back to the calling routine. Now, when we developed the code for output purpose, we didn't need to send anything up into the function because the function did all the work. In the type 3 function that we have here, the way that we wrote this particular function is we didn't send any data to that function, getData, because the getData function was going to ask the user for the data. If we had asked the user in function main, what is the input data, we would have to send that data to the function. However, in line 42, we have a type 2 function called process data. And in order for process data to do its work, it needs 2 numbers, value 1, value 2. Now, what I'm going to do here is I'm going to put 2 variables here. Now, One of the things that I need to share with you, which is the most abstract thing you're going to have to know related to functions. Recall when I said earlier that the variables within a function are local to the function, which means that if I tried to print, for instance, the value of x, if I just said in function main, print x, the Python would actually return an error because it doesn't know what x means unless you pass x back and forth between the functions. Since value1 is only known in main, we now have to send these two variables to a connecting variable in the parameter list. So I'm going to call this V1 and V2. So the way that Python is going to treat V1 and value1 and V2 and value2, imagine, if you will, like a rubber band connected between these two variables. Since value1 is the first variable in the parameter list of the function process data, it makes logical sense that when we define the function process data, that the first variable that is found in the parameter list will be associated with the first variable in the function call. The function call is in the calling routine. The function process data is sending two parameters to have something done with. So when I call the function process data, it takes value1 and transfers or maps the contents to the variable v1. It also takes the contents of value2 variable and assigns it to the variable v2. Now I could use v1 and v2 within the program to do any work that I need. So the function process data now knows what value1 is and what value2 is, because the values were mapped or sent to the function and assigned to v1 and v2. So we're going to write the program, we're going to write this function just like we had described it, so you can see how it works. All right, so now that v1 and v2 currently hold the values from value1 and value2, let's see what we've got. So I'm going to declare and initialize a variable called sum that I could use to hold the sum. And according to the function, the variables that are holding the values that we need to work with are v1 and v2, the parameters that are listed in our list. Okay, so sum is equal to v1 plus v2. I've done my work for the calculation. Now what I have to do is I'm going to have to print what the sum is, because I chose to make the called function process data a type 2 function. So the data is not going to be returned back to the calling routine, but rather all the work is going to be done here. And when the function code is done, it'll return back to the calling routine, and then we'll be done with the program. So what I want to do is I want to say print the sum of first value plus the second value is sum. Okay. And I'm done. So I'm going to put a return here so I can return back to the calling program. And then notice that it says return, which I'm done with the code for the main, and the program is finished. So what I'm going to do now is I'm going to go through the program exactly like Python would upon execution. I'm going to go through this without stopping. I've talked about each piece just quickly before I go into that one piece. We have actually, how many functions are in this program? We have 4. Okay, we have an output purpose, which is a type 1 function. We have get data, which is a type 3. We have process data, which is a type 2. And you say, well, how the heck do you know that? Notice that there's no parameters being sent to the function, and we don't have an assignment where the return data is being assigned a variable. We don't have that here. So according to the definition, this function neither passes nor returns any parameters or data. Classic example of a type 1. The type 1 function is going to output a purpose and return. The second function called getData, it's accepting no parameters. However, it is returning data, which qualifies it as a type 3 function. According to the definition, this function allows parameters to be passed and doesn't have to, as is the case here, but it also returns data to the calling routine. In our case, the calling routine is function main. The data is returned and assigned to the variables on the left-hand side of the equal sign. The number one error that people make in programming when they get into functions, if they have a type 3 function, the type 3 function is returning data, but they didn't assign it to a variable, so Python says, okay, I won't use it, and it continues moving. And that's when people start getting into trouble because they don't know where the data went. Finally, we have a type 2 function called process data. It's accepting 2 parameters from the calling routine, and it's going to actually add these 2 values together, print the results, return back to the calling routine. The main program then is over. This is actually optional. You don't have to put the return. It's best to be consistent because each of our functions actually have a return. So there's no more code to execute, and the program will terminate. So with that in mind, let me show you quickly how Python is going to interpret this. Upon execution, when you do a run, Python will look at the top of the code and see 4 comment lines. It will then go and find all the def syntax lines and say, we have a definition called output purpose, and inventory that. We have another definition, get data. We have another definition, process data. One more definition, main, and stop. It will then run through the code again from the top, knowing that it has all the definitions inventoried. It'll look for the first executable line of code. Now, none of these lines of code in any of the functions will execute until their functions are called. That's the reason why it doesn't execute these lines of code until we first execute line 53, which says, I need you to execute a function called main. Python knows that main exists because it inventoried it on the first pass. It then goes into main, declares and initializes 2 variables, value 1, value 2 to 0, executes the output purpose function. It knows exactly where to find it. It temporarily suspends execution of the main function, and control is passed to the output purpose function. Now, there are no variables in here, but there is 2 print functions. It executes them and returns back to the calling routine, which is just after line 44. The next line of executable code is the execution of a function called getData. But in order to assign value 1 with a value, we have to go to getData first. So we go up to getData. There are no parameters being sent in. So we execute 2 declaration initializations, xstring and x, null and 0 respectively. We then ask the user for an integer. We use try except logic to find out if the value was entered correctly in terms of data type. If it is, it returns the value that's entered in integer form and assigns it to the variable value 1. That's what the return does. Python must have a variable to pass the data back to in order for the program to function properly. We then execute line 47, which is the same function. We then suspend execution, temporarily suspend execution of function main. We transfer control back up to get data. We declare and initialize the variables get x string and x, ask the user for the value, use try except logic to make sure it's the valid data type, return that value back and assign it to the variable value 2. Next line of code, line 49. Take the two values that are currently holding the values that have been verified in the getData function and pass them into the function called processData as parameters. So we're basically transposing variable 1, variable 2 as the two parameters. We pass control. We temporarily suspend execution of function main. We pass control to processData. And we pass the two values from main into processData. Now, if you're thinking you could use the same variables in processData as you do in main, so in other words, value 1, value 1, could you do that? Yes. Do I recommend you do that? Absolutely no. We mentioned before that variables within functions are local to the function. Technically, if we put value 1 and value 2 here, while visually it appears to be the same variable, it's really not. That's why I like to make an association, value 1, v1. It's almost the same because v1 is a separate variable. Then value 1, it'll transfer or copy the value into v1 and v2 respectively, but they are not the same variables as value 1 and value 2. So we pass these two values, the quantities held in these two variables up to v1 and v2, and now for the entire life of this function, we're able to use v1 and v2. Not value 1 and value 2. So Python executes the first declaration, initialization of a variable called sum equals 0. We then take whatever value was transferred to v1 and whatever value was transferred to v2 and add them together. We then output what we need to. We return to the calling routine, which in this case, the calling routine is main. We go to the next line of code. This is the remaining code, which means return, we're done. So that's what Python does in a rather high rate of speed. So let's run this program and see what it does. And hopefully it'll work out. If we have any problems, we can fix the problem. So let's go ahead and run the program. And please enter an integer to use in our application. Now, before we did that, notice what it did here. It says this program will demonstrate the use of the functions to process user data, which means it executed output purpose. It went up, outputted the purpose. That's even such a word. It output the purpose, I guess you would call it. Then it says return. It returned back to the calling routine. And now we're executing the first get data execution. How do we know that? Because if we go to get data, please enter an integer to use in our equation. That's exactly what it's asking for here. Now I'm going to deliberately put in some gibberish to see if the try except logic works. It's working. I'll do it again. It's working. Now what I'm going to do is I'm pressing the number 4 and press enter. Now, if this works, what's going to happen, it's going to return 4 back to the calling routine and assign 4 back to value 1. And then it's going to execute the same questions the second time so we can acquire value 2. I'll press the Enter key. Notice that it's saying, please enter an integer to use in our equation. Now, it almost looks like it's asking for the same number again. We may have to tweak that output verbiage a little bit, but it is working. I'm going to go ahead and press 5. And once it returns the 5 back to the calling routine and assigns 5 to value 1, we're then going to pass 4 and 5 to the function called process data. We're going to come into process data, add the 2 variables, and then output the sum of 4 plus 5 is 9. Let's see if it works. Press enter. Success. We got it to work. So this is an example of actually creating function-based code so that you could call functions again and again. In this particular block of code, I'm going to shut my output tab off. In this particular block of code, we wrote a function called getData, and we used it twice. If you didn't have this ability, you would have to repeat the block of code to first ask and then verify your data twice. If you had 6 pieces of numerical data you wanted to acquire, you'd have to repeat that try except logic 6 times. Using functions, you write it once and call it 6 times, using the example of 6 pieces of data. So this is an example of how to generate a function-based application where each function has its own purpose and tasks. And this is used as a practical demonstration of how to use not only functions, but how to implement some of the information that's been provided for you in the course text, as well as some of the notes that I provided in lesson 3.